Hello everyone, my name is Anubhav and today I'm going to talk about Cassandra DB. Now this database has become so popular and it has been a buzzword in the last couple of years that it has forced me to go and read about it and then in fact try it out. So today I'm going to share my first-hand experience with database and share why this database is needed and why you cannot live with a single node, single cluster databases. But before going ahead with why this database is needed, we would need to understand the history of databases. That is how the journey of databases started from a single node, then going to primary, secondary, and then going to sharding. So it's very important to understand the reason behind a particular technology. We cannot just say that this technology exists without any reason. Without a reason, a technology is as useless as anything. So I'll start with the simplest database today and then move forward by adding more and more complexity to it. So let's start with the simplest database now. Now let me create a single node database. So now as you see, it's a simple database where we have a database running on a single machine. This machine can be any VM or a physical machine, or it can run on any of the operating system, be it Linux or be it Windows. And the user would connect to the database using a traditional model, that is make a connection using some of the database clients or use the code like Java or C# or Python code to connect to the database and get the result. The first problem is that now, since this is running on a single VM, so we are limited by the size of VM. By this, I mean that you cannot ingest or you cannot have anything in the DB more than the size of the hard disk. So if your hard disk supports only 1 TB or 2 TB, then you cannot go beyond that. The second is that there is no backup, which means it's a single point of failure. You have a DB and then you get a DB failure or the machine crashes. So these things can happen in the real world as well. The third is that you have a single read and write. So you cannot tune the read and write request. So there are many problems of this particular system where you have just single database and you are trying to solve everything using a single machine. So it might be good example for a dev machine, that is you are doing your coding on your own machine and you want to test anything, but definitely not something recommended or used anywhere in the world for the production systems. So now we'll make it a little more complex and go on to the second generation of the databases which replace this one. So as you see, this is the second category of the database. Here what we did was that we created a secondary DB. With the help of the secondary DB, we get the logs of the primary DB and keep a copy of the main database. So here the advantage is that now you have a backup. So the first problem got solved, that is now you have a backup. But the second problem, the size of the database, has still not been solved. The third is now we are having the write operations happening only on the primary DB, and read can happen from both primary or secondary. So now we are able to tune the read and write limitations as well. So if you want a faster read and you can compromise a little bit of consistency, then you should use the secondary DB. And thus there would be a little bit of lag between the primary and the secondary DB. It might be of a few seconds, or at times I have never seen more than a minute for the sync, but yeah, they can happen based on the delay it takes for the transactions log traveling from the primary DB to the secondary DB. So this solves the problem of backup and tuning the reads and write, but still we are limited by the size of the DB. And there is one important point I wanted to share is that MS SQL, MS SQL, they have limitation of 10 GB per node. So if you go to their documentation, you would find that you can only store 10 GB of information in a single node. So still the limitation holds. But in the today's world, do you really think that 10 GB is enough to live for any company? You would easily overpass this limit. So you would need a bigger or a better approach. So this introduces us with the sharding. So now let's quickly move on to the concept of sharding, which is the third generation of the approach. So what do we do in sharding? So as you see, we have multiple databases here, db1, db2, db3, and in fact you can grow as much as dbn. There is no limit to it. You just added one more layer here. So a request comes, and with the help of load balancer you can direct the request to one of the databases, and the sharding can happen with the help of various approaches. Okay, let's take an example. Say you have a food delivery app. You might choose that the information of Delhi based restaurants are stored in db1. The information of Bangalore based restaurants can be stored in db2, and Hyderabad might be stored in db3, and you can live your life happily. That is, you can divide in this way. The second approach is using the modulus function. You don't want to care about these Delhi, Bengaluru, Hyderabad, and you do not have such logic in place. What you do is you get input from the source. Say you get a key, you define a key, and with the help of key you take a hash function, you take a hash of key, you get some value, some integer value, you take modulus, and then you put the data to the particular node. So even this approach is quite common, that you get a input, you take a modulus, and then you redirect it to one of the nodes. But there is one problem. The problem is around the rebalancing. By rebalancing, what happens is that, let's say you have 4 databases for now and you want to increase one more. So in those cases, your modulus function would change. So you can read more about this in the consistent hashing topic, where it explains that why the scaling of shards is a little hard. So if we conclude, what are the problems with the sharding? So the first is the ever growing db, which means that if today you need 1 TB of storage and you have 10 shards, and tomorrow you need to increase one more shards. So let's say today you have db1, 2, 3, 4, 5. Let's say you have these 5 databases, and you have been having the modulus 5 to give the information to one of those. Now tomorrow if you need one more db, let's say db6, because all of these dbs got filled, in those cases you would need to rebalance. So this rebalancing is a little harder concept, and it's definitely not trivial, and you cannot just rebalance every day. The second is that you need to have some application logic in your code to check which shard you need to connect to. So for example, you have a Java code and you are connecting to one of the shards, db1, db2, db3, etc. So you would need to have some logic in this Java code around the shards. There are some libraries which help you to figure out which of the shards to connect to, but at the end of the day you are having logic in your code that which shard is there. So these two problems are still there. And the third is that, of course, the cross shard queries are a little hard to do. So it's not as easy to query from multiple shards and get the data. This moves us to the solution to all these problems. The main problem which is still there is the ever growing DB, and this has been solved by Cassandra. So if you have a use case where your data is continuously growing and you do not want to buy all the space on day one, you do not want to buy thousands VM on day one, you can use Cassandra. So Cassandra is a distributed database which will help you solve the problem of ever growing DB. So I will quickly list down the advantages of Cassandra so that you would understand the nuances and the use case. Because if you can use a single node database, please go ahead and use it. Do not use Cassandra just for the heck of it, because Cassandra comes with a logic of distributed systems and it will try to help you as much as it can, but at the end of the day it will have more complexity and the maintenance cost. So the first thing which it solves is it is linearly scalable, which means that today if you need 10 nodes, you have 10 nodes. Tomorrow if you need one extra node, just add one extra node in the configuration and you are good. You don't need to think about rebalancing, you do not need to think about scaling, etc. The second thing is that it has a tunable consistency. What do you mean by that? So you can set up the consistency level as a single node, quorum node, or all node, or there are various other things as well. So you can have a consistency that single node, one node. That is, if I have a cluster of nodes and I give a write or read request, I can request that, hey, I just want one node to give me acknowledgement and I'll be good. Or I can give quorum node, which means that I want n nodes to respond to me. Let's say I give a read request and I want 3 nodes at least should respond out of 5 nodes, and then I'll be success for both read or write. Or I can even give all nodes. So these things are configurable in Cassandra. You don't need to think about these consistency level on day one. You can in fact decide these consistency at query level, that hey, my query 1 needs acknowledgement from all nodes, my query 2 needs acknowledgement from only one node. So in this way you can tweak the performances of the query one by one. The third is it supports replication as well. So you can have a replication of the nodes. That is, if you have 5 nodes, you would want the data to be replicated to the other nodes. So it helps us in the replication as well, that the backups are also maintained and you get everything out of the box. You just configure in the Cassandra configuration file and then you are good to go. The fourth is that auto detection of the failure node. So these things you are getting out of the box. This means that Cassandra has something called as gossip protocol, in which if you have multiple nodes, these circles are represented as nodes, they communicate using something called as gossip protocol, and these heartbeats are sent to each other every second, and with the help of this gossip protocol they are able to detect which of the node might be failure. So eventually they kick out that node, so you don't even need to worry about which of the nodes would go down. And the fifth point is that Cassandra also supports topology by data center and racks. So this means that in a data center, for example, Google has their own data center, Microsoft also has their own data center. What they do is that they have machines stored in the data center with the rack numbers. So here you can configure to the level, the granularity level of the racks as well in their configuration. So they have a simple topology, then there are some advanced topology which are supported in the Cassandra, with the help of which you can have these clusters. So here you can have the various nodes in various data centers as well, so that the backups are also maintained. So let's say if you have machine 1, machine 2, machine 3, machine 4, you can even configure that machine 1 is in data center 1 and machine 2 is in data center 2. Machine 1 can be in a data center owned by Google, and machine 2 can be in a data center owned by Amazon. So Cassandra is agnostic to the platform provider as well. And of course, you can have a different data centers and different racks. In this way, the communication between the nearby racks will be faster, and you will have a better backups of the systems. Even if the AWS goes down, and if you have a backup of the Cassandra cluster in the Google's data center or Microsoft data center, you will still be safe. So this is a great point which you get out of the box. I'm not saying that these things cannot be configured in the other traditional databases, but here you are getting from day one. This particular database has been meant for large scale, thousands of nodes, petabytes of data, and still it will always be up. So this is a distributed database which takes care of the various failures which might occur, and these scenarios have been judged and analyzed while creating the system. And while building this system, the analysis of the previous databases have already been done. For example, the design of Cassandra has been highly motivated and inspired from Amazon's DynamoDB and Google's Bigtable. So you can learn any one of the distributed databases, and it will definitely help you to become a mature choice maker of the right database or the right tool, and someone who can map their requirement with the right system. So that's all from my side for this particular video. Till the next time, bye.